Hello everyone, this is question 34 of grade 28 in chemical engineering paper from the subject of heat transfer, and the question is: an insulated storage tank contains 1000 kg liquid of specific heat 10 kg per kg 10 kilojoule per kg Kelvin. The liquid is heated by saturated steam condensing in a helical coil at a temperature of 180 degrees Celsius. The heat transfer area of the coil is 0.1 meter square. If the overall heat transfer coefficient is constant at 1000 watt per meter square Kelvin, then the time in hours required to raise the temperature of the liquid in the tank from 20 to 40 degrees Celsius is dash. So for the given setup of this insulated storage tank, we have been asked to find the time in hours required to raise the temperature of liquid in the tank from 20 to 40 degrees Celsius. So let's just consider a tank. So from the given question, we have an insulated tank. And it has some liquid with a specific, and the mass of the liquid is 1000 kg. The specific heat Cp is given as 10 kilojoule per kg Kelvin. Let's just change this into joule per kg Kelvin. So it will be 10 into 10 raised to 3 joule per kg Kelvin. The liquid is heated by a saturated steam in the condensing helical coil. Okay, so let's just consider a helicoil coil inside the tank, and the temperature is 180 degrees Celsius for the helical coil. So just our temperature of coil is 180 degrees Celsius, and the area of heat transfer is 0.1 meter square from here. The overall heat transfer coefficient is kept constant. U is 1000 watt per meter square Kelvin. Then the time required to raise the temperature of liquid in the tank. Okay, so my T initial is 20 degrees Celsius and T final is 80 degrees Celsius. So from the given setup, we can write the energy balance. So usually the energy balance is written as mCp delta T is equal to m dot Cp delta T is equal to UA delta T. So that we can rewrite it as the mass present in this system into Cp into dt upon T. Here the temperature will be changing with time because we have been given an unsteady state system, and this will be equal to the temperature what the heat gained or lost by the fluid. So that is given as UA delta T. So we will just replace the values over here. So mass we have been given 1000 into Cp is 10 raised to 4 from over here. Then dt upon dt we have to find overall heat transfer coefficient. U is given as 1000, area is 0.1 meter square into delta T. So yes, in this case the delta T is the heat exchange between the fluid and the helical coil. So that is delta T is the, for the coil, the temperature we have defined as T coil, minus T is my temperature of the fluid. So the temperature of coil we have been given as 180 degrees Celsius and minus T. So this is my delta T. So this we can write it as thousands will get cancelled and this will become 10 raised to 5 dt upon T is equal to 180 minus of T. Correct? So this we can also write it as 10 raised to 5 180 minus T dt is equal to dt. Now we will be integrating this equation. to find the temperature variation along with time. So, yes. So initially the temperature was 20 and finally it becomes 80. So 20 we have considering time as 0, and we have to find this time at which the temperature becomes 80 degrees Celsius. We can integrate this as minus of ln of unity minus t. It will go from 80 to 20, and we will do 1 over 10 raised to 5 into t minus of 0. So yes, now we can replace the corresponding values and it will become so you can replace all these values and you will be getting this term as 0.47. So time will become 0.47 into 10 raised to 5. This will be in seconds and you need to divide it by 3600 since we have been asked to find the final answer in hours. This will become 47,000 and the final answer will come somewhere around 13.05 hours. Yes, in this given question, we wrote the unsteady state mass balance, that is MCP delta T equal to UA delta T, and find that time required to raise the temperature by the given delta T. And the final answer is 13.05, and we have to write it in second decimal places. So we will report the answer as 13.05.